Hello, everyone. I hope you all are very good. Today we are coming with another AI important session. Again, we are welcoming everyone to join in our AI for everyone, right? So just a quick recap what we have done, right, so far. So we are targeting AI in the both the ways. As we know, the AI is our future. Without AI, we cannot survive, right? I'm telling again and again that it is very, very important for all of us to know the AI very, very well. So what we are doing, we are targeting two ways, right? One way is we are learning what is the AI, what is supervised learning, what is regression, what is different kind of algorithms, right? And another way is we are also learning Python, right? So we already covered couple of sessions which covered basics of AI, linear regression, logistic regression. Today we'll be covering one of the very important topic, confusion matrix, right? And I am committing to you in this forum is after this session this confusion matrix will be resolved. There is no confusion. It will be without confusion matrix, because you will be learning in a very English, a very layman language and very easy way, where you will be learning with the examples so that there is no confusion within the confusion matrix, right? That is one way. Another way which we are doing, we are also learning in depth Python, which is required for AI/ML. We are not going through those Python which is required for data engineering or any other stuff. Our target and focus is only AI, so we are covering that as well, right? So without wasting any more time, let us concentrate today about the confusion matrix. So I'm sharing my screen like earlier sessions. If you have not seen my previous videos, I would request you to please go through those. It covers few of the important topic with the examples, right? And if you can understand that, it will be easier for understand this session as well. Okay. But if you have not went through, no problem at all. Please, just listen to the story and certainly you will be understanding. Okay. So with that, I am sharing my screen. Right? Okay. So before we jump into this confusion matrix, let us understand what is the story behind it, right? So we have created multiple algorithms, right? So for the machine to learn, because machine, you need to tell the machine, you need to train the machine, and we segregate the data based on the train and test, right? So that is why we generally manage it in such a way that the confusion matrix, what we'll be creating, it will help us to identify how good your machine learning model is. So you train the model, you decided which algorithm to go. Is it the algorithm which you will be going with, logistic regression, or you will be going in the linear regression? So what kind of model which you will be choosing, right? How you will be determining that your model is giving correct answer? There could be multiple algorithm, you have tried multiple. This confusion matrix will help you to determine which model to go, right? So for that, I have created a diagram. So just to ensure that we are not wasting any time, so that we understand directly here. So think about this particular part. What we know that in we have some actual values and we have the predicted values, right? So we keep the actual value in the y-axis and we keep the predicted values is the x-axis. What is actual? Which is actually happening. What is predicted? What is machine is predicting, right? So we need to, during the training process, so there is a training and test, right? So which we already discussed, 70% is the trained data and 30% is the test data. What we are saying that when we are doing the training process, we need to check this confusion matrix and how much is the answer which is coming. Okay. And based on that, we can decide, right? So we are saying this is actual and this is predicted. And within that, we have the 4 parameters, which is very important to understand. Today, I will be telling you in such a easy way so that you can understand very, very easily and you can digest it by heart. Okay. So let us take an example. Let us take an example that there are a patient, right, who has come to the doctor and you need to tell it, is it a, true positive, means or true negative, right? So basically what we are saying that there are actuals. So think about some diabetic patient which are coming, right? And we are saying that actually they are not diabetic. Okay, so this is actually they are not diabetic. This particular row which is ensuring that actual, right? And we are saying that yes, they are actually diabetic, right? And what machine learning has predicted, no, they are not diabetic, which machine learning is predicted here. And here machine learning is predicted, now it is diabetic, right? So this is yes. So this is the way it has been distributed. Now, what we are saying that, say we have 165 result, and out of 165 result, we have distributed 50 here, 10 here. So out of 165 result, we need to see that how it has been distributed in this confusion matrix. So before we go to this 165 record, we'll be seeing that how we can plot it, these values, right? Okay. Now, think about this situation, how we can put this value. We don't need to remember. You can easily understand. If you understand, you can write it by your own. So what we are saying, so suppose this patient is not diabetic and doctor is also suggested he is not diabetic, or think about the model is also suggested is not diabetic. So both the cases, what we are saying, it is true negative. That means this no, so since it is no, means he is not diabetic, right? For both the end, so we are saying no here, right? And T is it is like indicating that it is predicted as a correct, which is exactly same as actual. So this one is actually the prediction. Prediction is correct or not. So with the actual, prediction is correct or not? Yes, prediction is correct. That is why it is true. Okay. And this in actually indicates no, he is not a diabetic, and actually he is not diabetic, and prediction is not a diabetic. So that is why it is N. Okay. Now coming to the this one. So basically again the same thing. This is N. So if the prediction is N, so we are putting N is here. But actually he is diabetic, but predicted as a non-diabetic. So it is a false, right? So since these things are not matching, actually is diabetic but predicted as non, so we need to identify it. So it is the wrong prediction which is happening. So for that, in this quadrant we write Fn, right? Now let's see this one. So actually is a prediction is positive. Yes, prediction is positive. So you put P, right? But actually he is a prediction is yes, but actually he is not diabetic. So again, it is a false, right? So we'll put false positive. Makes sense? Again, actually, actual prediction has happened positive. That means it is P, but actually he is diabetic, and prediction is also diabetic. So it is going to T. Okay, so this is the true positive. So I hope it is clear how to put TN, FP, FN, and TP. I'm just quickly reiterating for you. If it is N, so very simple to digest that. If it is no, here the prediction is no, so you put N in both the angles because prediction is no, they are not diabetic. Now you need to see that what is actual. So actual is T. So basically these two are actually matching. That means it is true. These two are not matching. That is false. These two are not matching. That is why false. And these two are matching. Both are yes. That means true. Right? So this is the way we distribute the data. Now, think about the example. So we have 165 record. Out of 50 are TN, 10 are yes, and 5 are, here, and 100 is TP, right? Now, question is how you calculate the accuracy, how you calculate the error rate, how you calculate precision and recall. So before we understand all this, the four terminology, we need to digest it very well so that it will be easier. So question is what is accuracy and why we need to identify the accuracy. This story we need to understand first. See, look, accuracy is very important. So you build a model and you want to check if model performance is well or not. How you will be checking? You will be checking with the accuracy. Very simple. Okay. This is the first point. Now the question is, after you check the accuracy, will the accuracy always give the correct result? So the answer is accuracy may give accurate result for some cases, but not all the cases, right? So let us take an example when accuracy gives the best result and when it is not. So when it is a balanced data, means the data is balanced, then accuracy is perfect. If you check the accuracy, if you get the 95% accuracy of a model, you can certify this model is good. Okay. But if it is a non-balanced data, then what is non-balanced data? We'll explain you in a while. Don't worry. If it is non-balanced data, then accuracy is not the perfect metrics for you to judge. Very, very important point I'm telling. If it is a non-balanced data, accuracy is not the actual metrics to judge it. Okay. So in that case, which one you need to use? You need to use precision, and you need to use one more thing, which is called recall, right? So you need to check recall and precision. Okay. So what is recall and what is precision? So recall is out of your actual answer, how much you are getting accuracy, how much you are getting, right? So that is equal to recall. We'll see in a while. And out of your prediction, how much you are getting, how much accuracy you are getting out of your prediction, that is your precision. Now, this is what we need to do for unbalanced data. Again, I'm telling, for balanced data, accuracy is fine. What is the logic of accuracy? We'll see in a while. But for just remember it, for balanced data, when the data is absolutely balanced, what is balanced? We'll see in a while. But just for a moment, you just digest. For balanced data, we are good for the accuracy. For unbalanced data, we need to go for precision and we need to go for recall, right? Now, you get recall and precision, but you need to also get a mean. Is it correct or not? And that is why we call in the confusion matrix, there is a term called the F1 score. So if you go for the F1 score, then you will be getting the average of precision and recall. And then you can understand that if you know how the model performance is for the unbalanced data. So the takeaway from this meeting is that if it is a balanced data, go for accuracy check. If it is an unbalanced data, go for precision, recall, and then do the F1 score to determine if model is giving perfect prediction or not. See, in this model world, everything is prediction, right? Prediction, how he is doing the prediction based on the mathematics, right? So that is why we need to understand this prediction which model is giving, it is giving perfectly or not. Okay. Now let us see. Again, I'm sharing my screen. So let us see some example of the balanced data and the unbalanced data so that it will be clear, right? So if I go to this page, so look here, right? So in the linear, when we studied as a logistic regression, just an example, we know that y, we do actually probability of y. Logistic regression is always probability. If you have, if you want to know more details, please go through my previous video. You can see that. And we want to get that it's the 0 and 1. And we also see that probability of y, is it within between 0 and 1 or not? So how we have calculated accuracy? The accuracy calculation is very simple. See, this is the balanced data. What we are saying that we have a 6 rows, right? And out of which 2 is actually matching. Like this one is actual and one prediction is also 1. That means these 2 are matching out of these 6. So we are writing 2 by 6. So we are saying that accuracy is 1 by 3. Okay. So this is what we are getting the accuracy. But sometimes, as I said, that 90% accuracy is not good for a model. How? This is the example. So what we are saying it here, see, this is the actual where 90% are 0, means they are not diabetic. Where is the predicted 90%, 100%, all the cases you populate as a 0. So what we are saying that these are like you know, prediction where the prediction is 90% correct. But this, do you think this model is good? No, the model is not good. Why? Because this is the unbalanced data. You see here, if 90% case, it has a 0 and the remaining case, it has a 1. So this is the unbalanced case where accuracy is not the correct metrics to judge a particular model. So very important, when you create a test data or train data, majorly a train data, and you will be checking the model performance with the metrics, you need to know if it is a balanced data or it is the unbalanced data. Okay. So if it is the unbalanced data, we need to go for the precision and recall. Now again, let's move to this. Now see that what is the formula. So when you are calculating accuracy, the accuracy formula is very simple. You need to see that TP, right? TP plus TN. So basically we have calculated TP we know that how the TP, that means what is the true positive. So wherever true is coming, right? Wherever true is coming, true positive or true negative, just do the plus divided by the total. So what is the divided by total? That is 165. So 100 plus 50 divided by 165, that is your accuracy. Now what is the error rate? So if you get accuracy of 0.91, then obviously the remaining is the error rate. So error rate we generally calculate is 1 minus accuracy, which is like 0.09, which you can get. Alternatively, you can just do it's the true positive, right? So you need to take false positive and false negative divided by total. You will also get the same result. Okay. So both the ways you can do. So if you are calculating, if in the exam they say that you need to calculate the error rate. So one way is you do the accuracy and then do 1 minus, or the alternative is you directly do the error rate FP plus FN divided by total, right? Okay. Now, till this point, I hope absolutely clear. Now, the question is when you will be doing the precision and when you will be doing the recall, right? So, as I said, for the unbalanced data, precision is important and recall is also important. So, what is precision? Precision is how much you are getting true positive when you are predicting the data. And recall is how much you are getting true positive when you are getting the actual data, right? So that is TP. So both the cases true positive, right? Which is true positive here, both the cases, because it's a prediction, and divided by prediction yes. So how much prediction yes is? So it is like a prediction yes is this 110, right? So 2 TP equal to 100, and prediction yes is 100 plus 10, which is this one. So 0.64, right? And then next recall. So again, the TP which you are getting this 100 divided by actual, right? So divided by actual yes. So which one is actual yes, sir? So actual yes is which one? So it's the 105. So basically this is the actual yes, right? 105. So we are getting 0.95. So now you got a recall and precision, and then you can say that this is what good for your unbalanced data. Now, how you know that? Okay, so from recall you are getting 95%, precision you are getting 64%, right? If you make it percent actually. But how you know that what is the model performances? That time you need to do the F1 score. Now let us see what is F1 score in details in below, right? So F1 score is actually the harmonic score, right? So harmonic score based on the precision and recall. And for that, the formula is very simple. The formula, what we do, that we do is P0 and R. So basically, we make it in a different way. We say that F10 is nothing but the precision of 0 and, basically precision of 0 means it's the actual, and, recall of actual. And F1 prediction equal to precision of prediction and recall of prediction, right? And then the formula is F1 equal to 2 PR, means prediction and recall divided by P plus R. So you got, say, for example, 90% and 100% for, actual, right? P0, right, for actual. So if the F1 score you need to calculate, you will be doing like that way, and you are getting, say, 18%. That means this 18% is not a very good for a model, but that is how you can identify what is the F1 score of a model, and by which you can say for unbalanced data, right, how much is the percentage you are getting, prediction accuracy you are getting, which is good for for the machine learning process or not. So this is the way we can calculate the data, right? So what is the takeaway from today's session? Today's session, a very simple model of the story is very simple. Simple is you created you have used the algorithm to train the model. It can be linear regression, logistic regression, KNN, decision tree, random forest method. But after doing this, after applying this algorithm, you are getting some output from the model. Now you need to check that if those models performance is good or not. How you will be checking model performance good or not? There could be two ways. One is the balanced data. From the balanced data, you can check the accuracy. From unbalanced data, you will need to check the precision, and then recall, and then F1 score. So based on the F1 score, you can determine that if your model is perfect or not. So this is the total takeaway from today's session. I hope you enjoyed this session. If you enjoy thoroughly, if it increases your knowledge base, please give a like, and please subscribe our channel to learn the AI. This session is AI for everyone. We have to learn AI, and I am telling you, if you learn this way, right? I am giving the this way lectures, and if you learn this way, I am pretty sure that you will be an AI expert in due course. Thank you very much. More sessions are coming. In due course, we'll be, as I said, that this the machine learning is going on. After that, we'll continue on the deep learning. Then we'll continue on the agentic learning. Before that, we'll be doing the LLM also. LLM, fine tuning, LoDA, QLoDA, DODA, everything we'll be learning. And then we'll be learning about the agentic AI. We'll be using the make.com. We'll be using Zapier. We'll be using NA10 to see that how we can create multiple agents. I have created at least 8 agents now, and which are working very nicely. We'll be showing to you how to create and how you can create by your own agent. This is the time of agent. This is the time of the new era. So let us work together to learn, right? So enjoy your day, and wait for the next session. Will be coming next session very shortly. Thank you very much. Until then, salute.